Okay, then we have the terms endothermic and exothermic. And in order to talk about endothermic and exothermic, we define them like this. We say that an exothermic process is one that
gives
off. So we say that it releases energy to the surroundings. And an endothermic process is one that absorbs energy from the surroundings. And this is one that's often confused here, but I'm going to underline the word surroundings, and we want to make this distinction here that the system and the surroundings are not the same thing. The system and surroundings, they're different from each other. And so when we look at a chemical reaction, we want to tell whether something is endothermic or exothermic. You and I are always going to be a part of which piece? The system or the surroundings? We're going to always be a part of the surroundings. So whenever we observe something, you and I are in the surroundings of whatever it is that we're observing. Or if somebody's observing you, then somebody else is going to be in the surroundings of you. So you and I always observe what happens to the surroundings. And based on what happens to the surroundings, we make a judgment of what happens to the system. So if a process releases energy to the surroundings, let's think of heat energy. If something releases heat energy to the surroundings, what do you and I feel? Is the temperature going to change?
Yes.
And how will it change?
Will it increase?
It should go up. So in an exothermic process, we'll observe a temperature increase in the surroundings. And in an endothermic process, we're going to observe a temperature decrease in the surroundings. So if we think back to day one, we had the exploding hydrogen balloon in here. The exploding hydrogen balloon, is that endothermic or is it exothermic?
Exothermic.
That's definitely an exothermic, because anybody that's in the surroundings, especially if you were up front here, what did you feel?
We felt more heat.
You felt a lot more heat coming off of that because it was releasing heat to the surroundings. You place an ice cube in your hand. What happens to that ice cube? It melts. And as it melts, what is happening to the temperature of your hand?
It's going to get colder.
It's getting colder. So in order to melt that ice, melting ice would be an example of an endothermic process, because it is absorbing energy out of your hand in order to melt. And so again, the surroundings are getting colder in terms of their temperature. So chemists, when we look at chemical reactions, all chemical reactions are either endothermic or exothermic. Sometimes we don't observe that change very easily because that change in energy is so small, but it is actually the driving force behind chemical reactions. Chemical reaction cannot take place unless there's some sort of change in that energy.